Hi everyone. In this video, we're going to review some solving quadratic equations. So I'm going to stick to, in this video, two things that we already know how to do. One, solving by factoring, and two, using the quadratic formula. So those are both things that we've either practiced together in class or that would be prerequisite knowledge coming from another class. So first, let's talk about solving quadratic equations of this form right here. That's what our goal is to be able to do. So eventually we're going to have three methods to do this, to solve. And these are going to be intertwined when we are graphing quadratics. You're going to see the use for these methods and why do we solve quadratic equations and what do they tell us about the graph. So the three methods that we have are by factoring, that we've done in class. So we're just going to do a couple more practice examples in here. The second method is called completing the square. And that would be my guess as to be the one that people have not seen before. When teaching high school, I know that was a lot of teachers, that's the method that they would skip if they were short on time. They would do factoring and the last one using the quadratic formula. So that's the ones I'm gonna do 1 and 3, this one right here and here. I'm gonna review them in this video, and I'm gonna save completing the square for in-person together because that's the one that's gonna be new to you. I can't stress enough the importance of learning completing the square because it actually is where the quadratic comes from, the quadratic formula comes from. So without that method, we would not have this formula to be able to use to solve a quadratic. So let's start with factoring. So I'm going to go to my next slide. I'm going to do a couple examples of factoring, and then I'll do an example of quadratic formula, and you'll see we're going to be practicing together in class when we go through our graphing quadratic section. So let's start with these. So again, we're going to just do our factoring method. And the two examples I want to do, each one kind of practices a little bit of something different. Let's start with this one first. X squared minus 11x equals 60. So you guys write that one down, and you can even start it while I'm writing this next one here. Both of these are doable for you to even do on your own, but especially the first one in yellow. So we've done this before. We know that if we have to solve a quadratic by factoring, our first goal, right, is to get everything on one side together. So I'm going to bring this 60 over because I really would like to keep my x squared positive so that when I factor, right, so we want one side to be 0 so that when we have our factors, we can set each factor to 0. So I'm looking for two numbers that multiply to negative 60, that combine to negative 11. So run through our factors of 60, right? There's no harm in kind of just going on the side and saying, okay, it could be 1 and 60, 2 and 30, 3 and 20. We'll just keep going until we find a pair that can make 11. 4 and 15. I think I don't have to go any further. I don't have to even go to the 6 and 10 or the 5 and 12 because 4 and 15 could make an 11, and I want it to be negative 11. So there's my factors that work. So what solution will this one give me? When I set it equal to 0, I will get a negative 4. And this one right here, I will get a 15. So my solutions would be negative 4, 15, right? X could be either one of those. So it's worth noting also here that this represents, both of these came out to be real solutions. So let me just move this up a little bit so I can add a little more. What else is worth noting, which we're going to do this several times, is deciphering these between being rational or irrational. Once we get ones that are irrational, I will show you what it looks like. But these are two real rational solutions. Okay, a rational number is anything that can be written as a fraction. Both of these could be written as a fraction. When it comes up, I'll show you things that are not rational, that are irrational. And these are real because nowhere in there did I use anything with an I. If you recall from the last video, our non-real or our imaginary solutions would be something with an I in there. Okay, so let's see, that's review. So let's look at the one over on the right. Also review, except sometimes this throws people off when there's no constant term. It actually makes things easier, so try not to make it harder than it is. Follow the same things you did on the left in yellow. And let's get one side to be 0. So I'm going to bring the 5x to the left because I would rather factor with a positive leading term. So the fact that there's no constant term in this actually means that rather than completely unfoiling, we're really just going to undistribute the GCF. So if we look at these two things, these two terms right here, what do they have in common? Is an x. So if I pull out an x, what I'm left is 3x minus 5. And you can see just by doing that, I have no more quadratic terms. I have the product of two linear terms. Whenever I'm solving a quadratic, I should have two solutions. So sometimes what we do by accident is we just think of that as giving us a solution and getting our, let's see if I add that 5 over, I have a 5. Divide out my 3, I get a 5/3. And that is true, that's one solution, which came from this factor. But there's another solution that comes from this factor right here. So if I set this one equal to 0, I just get a 0. There's nothing more to solve. So anytime I factor out an x at the beginning, it means I'm going to get 0 as one of my solutions. So my solutions would be 0 and 5/3. So I never actually had to like unfoil there. I really just had to pull out the GCF. None of my solutions have I in it, so they're definitely both real and they are both rational. So let's take a look at how else answers could come out. And so we're going to go on to quadratic formula here. So let's try to do, we'll look at, this is method 3 we said in the front, using quadratic formula. All right, so let me just write the quadratic formula as a quick little review here. So if we're trying to solve something of this form, using the quadratic formula, the formula tells us that our solutions, our values for x, can be found just using a, b, and c, using all of our coefficients. So there's a song that goes with it, but I'm pretty sure nobody wants me to sing it, so I'm just going to say our quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So all the quadratic formula did for us is it solved for x for us. And it said if you can find these solutions just by using a, b, and c. And notice this plus or minus in here is how we get our two solutions. So let's say we were doing something like this. We were trying to solve 5x to the second plus 5 equals 8x. And we want to use quadratic formula. So if we come back to this line right here, we see it does have to be in that format for us to start plugging a, b, and c in. One side has to be 0. So this is not quite ready. No matter what method we chose to solve this one, we do have to get one side to be 0. So I'm going to choose to bring this over here, and I would like to put it in the middle because when we look at a, b, and c, it's easiest if they're in order of our descending powers of x. So I'm going to put it right in the middle of those two terms. And I'm going to pick out my a here is 5, my b is -8, and my c is 5. So let's see if we can use our formula here. Oops. Just going to move it up a little bit. Okay, there we go. and plug into our A, B, and C. So this is saying x should be, okay, opposite of B. So B already is -8. So the opposite of B would be 8 plus or minus -8 squared. I put that in parentheses so I square the whole thing. Minus 4 times 5 times 5. All over 2 times A, and A is 5. So the quadratic formula is really not conceptually hard at all because you're just plugging in, but there's a lot of room for arithmetic mistakes. So you have to be really careful under that radical and deciding, you know, what stays negative, what becomes positive. For example, that -8 squared, right? That should be a positive 64. And then that minus 4AC could easily become plus if either A or C is negative. So we just have to be really careful of our arithmetic. In this case right here, if we do minus 4 times 5 times 5, we have minus 100. It stayed negative. It stayed a minus because A and C were both positive. All over 10. So that's what we have so far. So we're just going to keep working on this and keep simplifying. So let's do a little bit more simplifying here. And so now we're going to say x equals 8 plus or minus, so underneath my radical is a -36 all over 10. So look at that. Back to what we did for another one of our videos, and we have a negative under the square root. So we're going to simplify it using I. Whenever it comes up, now we'll use I. So I'm going to rewrite this as 8 plus or minus. All right, so -36, the square root of -36 is going to simplify to 6i. So right now I know that these are two imaginary solutions. Or actually a better way to write it would be two complex solutions. Because I have I in it. But I can see a little bit more that I can do because I can see right here that there is, if there's a number that can come out of everything, sort of like when we were doing the difference quotient and we canceled out an H at the end of everything. Same thing here. I can see that there's a 2 in common to all of these. So I'm going to reduce by 2, which makes that a 4. This is a 3, and that's going to become a 5. So in lowest form, this is going to become 4 plus or minus 3i all over 5. So I could separate this into two different solutions if I want. I could say 4 plus 3i over 5 and 4 minus 3i over 5 would be my two solutions if I had to separate them. So two complex solutions. We did not end up getting real values out of this because we have an I in our answer. So my question for you, and I'm going to ask this many times when we're graphing these, is what does that mean about the graph? If I were graphing this one and I got solutions like this when I solved when the output was 0, what does that tell me about the graph? It tells us something, definitely. So give that some thought. And then you'll see as we graph these next week, we will continue to practice these methods of solving.